My name is CHOU. Today I'm going to explain probability homework 10 with question 1. So from the lecture note page 1 to 50, collect the definition and simple probability like probability mass or density, mean, and autocorrelation function of example of stochastic process. So the first one we want to introduce is the Poisson process. So you can see my note here. So the number of T1, T2 of the point Ti in the interval T1, T2 of length T is equals to T2 minus T1. And due to the Poisson process, we have the probability that T1, T2 equals K will equals to exponential negative lambda T times lambda T K divided by this. And also, if the interval T1, T2, T3, T4 are non-lapping, then T1, T2, T3, T4 are independent. At the time moment, this is no more than one Poisson point. And for the first order probability mass, we can write that here. And the mean is equals to lambda T, and the autocorrelation is equals to lambda squared times T1, T2 plus lambda times mean T1, T2. And the autoconvergence is equals to lambda times minima of T1, T2. And this is the simple property of Poisson process. And for the second, we want to introduce the Poisson increment. So the first order of probability mass is equals to exponential negative lambda epsilon times lambda epsilon power of n and divided by this. And the mean is equals to lambda, and the autocorrelation is equals to lambda squared when T1, T2 is larger than equal than epsilon, and this equals to this when T1, T2 is smaller than epsilon. And the autoconvergence is equals to 0 when T1, T2 larger than epsilon, and equals to this when T1 minus T2 is smaller than epsilon. For number 3, we want to introduce the Poisson impulse. And the first order of the probability mass is not defined, and the mean is equals to 0, and the autocorrelation is equals to lambda squared plus lambda times the impulse function of T1 minus T2, and the autoconvergence T1, T2 is equals to lambda times impulse function of T1 minus T2. And for the question 4, we want to introduce the semi-random telegraph signal, and the first order probability mass is equals to this when the xt is equals to 1, and it equals to this when xt is equals to -1, and the mean is equals to exponential negative to lambda t, and the autocorrelation is equals to exponential negative 2 times lambda absolute value T1 minus T2, and the autoconvergence is equals to this. And for the question 5, we want to introduce the random telegraph signal when the probability mass is equals to 1/2, and the mean is equals to 0, and the autocorrelation is equals to this, and the autoconvergence is equals to this. And question 3, we want to introduce the random walk. So the probability mass is equals to this function, and the mean is equals to 0, and the autocorrelation is equals to mean nm times s squared, and the autocovariance is equals to the autocorrelation. And for question 7, we want to introduce the winner process, and the PDF is equals to this function, and the mean is equals to 0, and the autocorrelation is equals to minima of T1, T2 times alpha, and also is same as the autoconvergence. Thank you, everyone.